this case, it is fixed at one support. For this case, it is fixed at two supports. Or sometimes it may happen that this is a support and here some internal supports are also here, the reaction forces coming from the supports. So what is beam? Beam is a structural member which is subjected to a system of external forces at right angle to its axis. If this is the beam, so what is the axis? It is in this direction. So what will be the right angle of this, its axis? This. So if some force is acting at the direction perpendicular to its axis on a structural member, that particular structural member is known as beam. B-E-A-M, beam. Whatever I have shown here, these are different types of beam. Typical we use in our structural analysis or say civil engineering analysis. So this is called cantilever beam. The characteristics of it is one end is fixed, other end is free, and the load may act anywhere, but that should be the perpendicular with respect to the beam axis. So this A type of beam is known as cantilever beam. B type of beam is known as simply supported beam. So here it is resting on two supports. So that's why simply supported beam. C, as both the ends are fixed, and for case D, whenever there are more than two supports are there, here it is more than two supports are provided for this particular beam so that it can rest and it can act, it can take the load. This is known as continuous beam. So these are four different types of beams. So this simply supports, so for this case, these are some supports fixed, just simple support fixed. Here for here it is fixed, reaction forces support. So for this case, if some loading which is acting at perpendicular distance of this beam, then some shear force and some bending moment generates in that particular beam. In this chapter, we will be trying to find out what amount of shear force and what amount of bending moments are getting generated if a beam is subjected by some loading. What will be the direction? The loading direction will be perpendicular towards the beam. Okay, so for now, here we can consider any one single case. Say this is the cantilever beam at this point of time we are talking about. Okay, say the length of the beam is 2 meters and one vertically downward load acting, say the load amount is 4000 Newton. we want to find out the shear force and bending moment for this particular beam. It is known as cantilever beam. So, whenever this beam is acted upon by a external force vertically downward to be in equilibrium, this support, that is a fixed support, it should provide some vertical reaction upward because this is acting downward. So if we want to keep it in equilibrium, and that's what it is, it goes like this. So one vertical reaction upward will be acting here. Say this point is A, this point is B, this is A and this is A. So what will be the, suppose if the reaction force we can denote is as RA, what will be the amount of this? It will be the exactly same amount because there are no other external forces acting on this beam right now. So whatever external forces are coming up, we have to find out the equal amount of reaction. So the reaction force will be equals to the applied force, but the direction will be the opposite. So it will be acting vertically upward. Now, if this is a 2 meter length beam and this vertically downward load is acting here, what will be the moment is generating in the beam? If we talk about that moment A, so here
it is 0.
Yes.
Sir, moment of A should be 0.
नहीं मैं बोल रहा हूँ कि what will be the amount of coming here? Moment will be 0, but why moment will be 0? Is it means is it allowed to move?
फिक्स्ड है सर इसलिए.
हाँ,
फिक्स्ड है वो.
फिक्स्ड है ना, तो फिक्स्ड का मतलब क्या है? फिक्स्ड का मतलब कि इट इज नॉट अलाउड टू रोटेट. मोमेंट कहां पे जेनरेट होता है?
रोटेशन अलाउ.
रोटेशन जहां पे अलाउ है, मतलब सो दिस पर्टिकुलर फिक्स्ड पोर्शन, the moments will be generated because that has to be in equilibrium with the system. What you are talking about, the moment at B will be 0 or the free end will be 0 because at this point of time no restriction is happening at B. क्योंकि B can move freely, so there is no moment is required to keep it in equilibrium. But the fixed support will not allow the beam to rotate. So that's why the moment will get generated here, because that is coming from the restrictions. Why this reaction force is generated here? Because this beam is not allowed to move downward as per the 4000 Newton acting. What is acting out here? It should go downward, but it is not going downward. Why it is not going downward? Because the fixed support is resisting that downward movement. To do that, it has to provide some reaction. Then only it will stay its in own position. And what will be the force required? Exactly equal and opposite force will be required. Similarly, this 4000 Newton will create a moment at A, that is something, this force into this distance, this couple will act here. So it will try to rotate the beam like this. Like this it will try to rotate. But why it is not rotating about this A? because it is fixed. So it is restricting the beam to rotate or completely move up. But ऐसा तो नहीं हो सकता है कि without doing so, to do that or to provide the restriction, it has to apply some moment. What will be that moment here? That is equal and opposite of the moment which is acting or which is getting generated by the external force. What is the moment here getting generated by this external force? Is
8,000 Newton
Two-
meter.
4,000 Newton, that is 8,000 Newton meter is getting generated. In which direction it is getting generated?
Sir, inside into the paper.
Means I am talking about clockwise and anti-clockwise.
Clockwise.
Clockwise it is trying. So to restrict that, our moment at A should be
Anti-clockwise.
anti-clockwise direction and of equal magnitude, that is 8,000 Newton meter in anti-clockwise direction. Then only this beam which is acted by this external force will remain in equilibrium. Okay, so this is the total reactions what are generated at the one free end B and one fixed support A. But we are interested here to find out the shear force and the bending moment for this beam. How we will do that? Say, suppose let us assume a section here. Okay, at any distance, this is our 4,000 Newton. Here also 4,000 Newton will act. Here an anti-clockwise resisting moment 8,000 into Newton, 8,000 Newton meter will act. Now we are assuming, or we have considered a section, say XX, say at a distance X. So if we look here, what is the natural tendency of this? If this reaction force was not there, this external force will tear it off this beam. Now, if we want to say that so here the natural tendency will be the cantilever will be sheared into parts. So for this case, if we want to take the right part, if suppose this section is cutting this beam into two parts, and if we are looking at the right part, so what are the forces acting here? The forces acting here is 4,000 Newton downward in the right side, and the forces acting on the left part is also 4,000 Newton or Ra acting upward. So let us again draw this diagram. So this right part and this is our, say, left part. So if we think about this right part at this moment, the total force acting on the right part is 4000 Newton downward, and it is RA and it is MA. And for this left part, the total forces are acting is 4000 Newton upward. That means this particular section X then we can say the total amount, the force coming from the both the parts, be it from right part or be it from left part, is 4000 Newton. This is called the shear force at this section X. So what will be the definition of shear force? The resultant force acting on any parts, resultant forces acting on any parts normal to the axis of the beam, so perpendicular to the beam axis, is our shear force, but at this section only. So to find out a shear force or to find out a bending moment, we have to assume any section. We can place it anywhere as per our wish and convenience, but we have to see, and then we have to visualize the beam in two parts. One will be the right part and one will be the left part, and we have to see that what are the total forces acting on individual part, the resultant of the forces acting on any of the parts, because from right side it is coming same value, left side also it is coming as same value. So that we can say that particular section XX, the shear force is 4000 Newton. So whatever forces are acting on any part, we have to take the resultant of that. Okay, then that value of the resultant forces acting on any parts perpendicular to the beam is shear force at that particular section. So here the section is XX. So for this particular section, the shear force will be 4000 Newton. So shear force at XX section is 4000 Newton. Okay. Now we want to find out the bending moment acting on the beam. We can assume the same cantilever portion. This is the external load. Here the support reactions coming will be acting in this direction, and this moment will be acting in this direction. This is say A and this is CB. Now we want to find out the bending moment. Why this terminology bending? Because it will try to bend the beam. So the moment which is trying to bending this beam, that is known as bending moment. So for this case, let us assume a section, say YY, say the distance is 0.8 meter. So this distance will be 1.2 meter because the total was, we have considered 2 meter. So this is a section I have selected. You can select anywhere. It should be within this section. and subsequently the values you have to be consistent with. So as we have considered this section from this free end, that it is lying at a distance of 0.8 meter. So again, we have to look, or we have to assume this beam in two parts divided by the section which we have chosen. So there will be one section right side, there will be one section left side. What is acting here? For this part, right side part, the 4000 is acting, and for the left side part, the 4000 is acting upward, and this moment is also acting anti-clockwise direction. This is the 8000 Newton meter. We know from the equilibrium point of view, we know these are the forces and moments are acting. We want to find out the bending moment at this section YY. And first we are considering the right part. So if we talk about here, if we think that we are standing here, so this 4000 will have a moment clockwise at this section YY. So this will create a moment 4000 into 8, 3200 Newton meter clockwise. So to be in equilibrium for this part, this one, for this right part, to be in the equilibrium, and reactive moment should act equal and opposite direction, that is similar 3200 Newton meter, but anti-clockwise. Because this is acting in the clockwise direction, the external force is creating a moment in the clockwise direction. And if we want to be in the, and if we want to find out the equilibrium for the right part, then another equal and opposite moment for this right part only we are talking about. So same amount of moment, but in opposite direction should be there. So for this right part, one anti-clockwise moment with the same magnitude, 3200 Newton meter, is acting. Now, if we want to talk about the left part, and if we want to see that what are the moments coming here for this YY section. So here, this is 1.2 meter. So 4000 into 1.2, this will act originally clockwise, and this 8000, which is already acting as a reactive moment, this 8000 will act as anti-clockwise. So if we do the resultant from here, we can see that 3200, this, if we do this part, okay, so if we, so this will be obviously one part will be positive, one part will be negative. So 32 Newton, this 3200 moment will be acting in anti-clockwise direction. This is acting from the external force or the reaction force, but we want to keep this left hand part in equilibrium. So we have to create, or we have to put another equal and opposite moment, as the other forces are generating anti-clockwise moment, for equilibrium, there will be a clockwise moment of the same magnitude. I am not writing them, okay, 2320 is the magnitude, same magnitude, anti-clockwise moment is acting. So if we want to have a clear picture, so this is our beam which we have considered, and if we want a section here, this is 0.8 meter and this is 1.2 meter. If we want to cut a section here, the section will have a reactive bending moment. This side will be in this direction and this side it will be in this direction, because so, and also we can see that for both the cases or both the parts, the value of the reactive bending moment is same. So if we come from any parts of the section, it will give us the equal bending moment value at that section, like if we want to come from the other parts as well. So both the parts will give us same amount of moment or bending moment at a particular section which we have considered. So what is the definition of bending moment? We can say it as BM also. So bending moment at a section, say YY. So what is the definition here? It is the algebraic sum of the moments of forces and reactions, acting on one side of the section. So section we have considered here at any distance as per our choice or convenience, and we have to look for the two parts, and at any parts, whatever the moments will be acting, any part, be it right, be it left, we have to consider all the moments coming from all the forces and reactions for that particular part, and then we have to do a algebraic sum. Why I am considering this algebraic sum? Because here one part was clockwise. So for this case, suppose for the left part, what we have done? We have considered the moments, this one, and we have considered the moment coming from this force, reaction force, and we have done the algebraic sum, because this part clockwise is one direction, anti-clockwise is the opposite direction. So if we consider one direction as positive, so other will be the negative. So that's why we have considered the algebraic sum, and that's why the minus or the reduction happened, and that's why this 3200 came up. This algebraic sum will give us the bending moment for.
Excuse me, sir.
Yes, बोलो.
सर एक मिनट पिछली स्लाइड खोलेंगे आप प्लीज.
हाँ हाँ बोलो.
सर इसमें जो हमने ये 4000 into 1.2 और सर ये जो हमने एंड यस सर इनका हमारे पास रिजल्टेंट 3200 कैसे आ रहा है?
कितना आता है 400 इंटू एट कितना होता है 4800 होता है ना
Yes,
Four
sir.
zero.
Yes, sir.
हाँ तो 4800 that is one clockwise if we consider this 8000 as positive in this
8000.
case so this
नहीं
minus
नहीं
this
सर, मैं सर ये नहीं पूछ रहा,
हाँ
मैंने
बोलो
पूछा सर कि जो मतलब हमने ये 4000 into 1.2 निकाला है
हाँ वो कैसे
सर, ये
आया
हम नहीं नहीं सर, वो राइट एंड के हम उसमें निकाल रहे हैं ना?
नहीं अभी हम लोग राइट एंड पे निकल रहे हैं ठीक है राइट एंड ऑफ द लेफ्ट पार्ट
ओके सर,
यहाँ पे हम लोग अभी यहाँ पे मतलब एट दिस सेक्शन सेक्शन तो एक ही जगह पे है ना सो
यस
सेक्शन
sir.
यहाँ पे भी है
यस
यहाँ
सर,
पे भी एक सेक्शन सेम सेक्शन इज हेयर आल्सो सो हियर
Yes, sir.
कितना मोमेंट आ रहा है वो हम लोग देख रहे हैं एट
ओके
दिस
सर,
पॉइंट
ओके सर,
नाउ इट इज क्लियर
यस सर,
okay so this 4000 will have a moment here क्योंकि ये तो है this a distance and moment automatic है 8000 and algebraic sum क्यों बोल रहा था because one will be positive one will be negative so I am not going to the positive negative as point of time I am saying clockwise and anti-clockwise क्योंकि वो हम लोगों का समझने में easy होगा from that part we can get an extra 3200 Newton in the anti-clockwise direction to counteract this moment we have to have some equal and opposite at the section to be in the equilibrium so this is the bending moment definition that algebraic sum of the moments of the forces and reactions acting on one side of the section be it right be it left so this is our calculation process to find out the shear force and bending moment for a particular section. But our work doesn't end here. We have to find out or we have to provide the shear force diagram and a bending moment diagram of the entire beam. Okay. So we want to find out SFD that is shear force diagram and BMD that is bending moment diagram of the entire beam. The beam was like this. Okay, this is the beam A and B. So originally this was acted, we have calculated the reaction force then due to the application of this. So initially the beam is like this, then the reaction force is generated at A. Now to find out the shear force diagram and bending moment diagram, we have to consider some thumb rules of sign convention. बिकॉज एक चीज शायद तुम लोग अभी देखे होंगे कि यहाँ पे देखो इफ वी टॉक अबाउट दिस shear force one is downward one is upward again for this moment one is clockwise see this one is clockwise one is anti-clockwise तो डायग्राम जब ड्रॉ करना होता है तब हम लोगों को तो वैल्यू के साथ साथ ये भी दिखाना पड़ेगा कि is it positive or negative but at this point of time we don't have any idea that what we should consider as positive and what we should consider as negative because then only if we do not know the positive and the negative value we have find out value पता चल गया कि shear force इस section पे है 4000 and bending moment is 3200 Newton meter value पता हो गया but diagram पता करने के लिए we need to know the plus minus signs and to do that there is a thumb rule of sign conventions. What is that? We have to remember these parts and please pay attention very carefully. So for shear force the first is that consider the left or right. Left or right. Okay, Means take a section at any place you want. Take either left or right. That is also is as per your convenience. Second is that add the forces normal to the member on one of the parts. Add the forces on one part. कोई भी एक पार्ट चूज कर लो, जितना भी फोर्सेस आ रहा है which are perpendicularly acting, that is this direction in which this 400, it may be upward also, that is also fine, we have to consider that as well, but we are not considering this portion, like means whatever is not along the axial we are not considering, we are only considering the perpendicular forces, be it downward, be it upward. We have to add all the forces on one part, and that will be our shear force. What will be the sign for right part? For right part, if the force is downward, we will take it as positive, and upward we will take it as negative. Okay, and if we want to look for left, remember this is not additive, left or right, कोई एक choose करने से we can find out the shear force. Okay, for explanation I have showed you both the parts, but for normal problems you need not to find out both the parts, you can choose any of the parts. You can cross check by yourself whether for both the parts the shear force and the bending moments are coming as same or not. जैसे यहाँ पे मैंने दिखाया कि दोनों तरफ से 4000 आ रहा है, दोनों तरफ से 3200 आ रहा है, so just to showcase you that it is coming same. For your part point of view, or when you will do or you will solve the problem, take any of the parts, so right or left. For left case, the sign convention is whatever the upward forces we will consider as positive, and downward forces we will consider is negative. At least 8 points note down kar lo, because it will help you. These particular points note down kar lo ki if we want to take this, if we want to draw the shear force diagram, first will be take any of the parts, either left or right, then उसी कोई एक पार्ट में जितना भी फोर्सेस है we have to add it up as per the sign convention. And sign convention says, if we considering the right part, then downward will be positive and upward will be negative, and for left part, upward will be positive and downward will be negative. Okay, so if this is fine, then suppose this is a section and here the right part is acting for any beam. We are not talking about this one, we are talking about any case for an example purpose. Suppose one force is acting here, one force is acting here, and one force is acting here. So what will be the shear force for this section XX? Have a look at this sign convention.
E plus Q minus R.
P plus Q minus R. Because Q, why you have considered? Because you understood that this is the right part we are talking about, and for right part, upward will be negative and downward will be positive. So for right section, this upward are P plus Q and R will be negative, so minus R. Very good. Now if for another part, say it is a left part of any beam, if this is a Q acting here and this is a two forces acting here, W1 and W2, what will be the shear force at this section?
Q minus W1 minus W2.
Very good.
Q minus W1 minus W.
Very good. Yes. Q minus W1. Sorry. यहाँ पे हो नहीं रहा. Yeah. Q minus W1 minus W2 will be the shear force for this section. How we are doing that? We are finding out, or we are considering any of the parts here, be it right, be it left. Then we are considering all the sign conventions here, and then as per the sign conventions, we are incorporating the signs against the forces, like, and when it is positive, so it's positive. When the sign convention is saying that it should be negative, we are putting a minus sum, and then we are adding the force there. So that's how this shear force diagram of any parts we can find out. And for bending moment diagram or bending moment, also there are some rules. First is said that consider the left or right, same rule as the previous one. Consider the left or right. Again, I am saying anyone is okay, either. Yes, Bolo. Yes, Bolo. Do you want to say anything? Okay. So either left or right. And second, it is saying that introduce all the forces, and reactions and find their effects at the section. Means so what are this is the external force, this is our reaction force, and this is our reactive moment. If we take a section here at any distance, say x, so introduce all the forces and reactions. So sare forces and all the reactions we have introduced. Now we are considering that's any part, and now we are looking for that what are the effects of these forces and the reactions at that section. So if you just if we go to the first problem, or the whenever we are finding out this 3201, what we are doing, we did that effect of RA here, that is the reaction forces. What is the effect, that what is the moment coming from the reaction force, and the reactive moment, it is also having an effect. So we have considered all the effects of these moments at this section. Now how we can find out that what will be our positive bending moment and what will be our negative bending moment? So if this is the, say this is the axis of the beam and this is the perpendicular direction. So this beam, say the beam was like this, if the tendency of the beam is like this by the bending moment, we can consider, so it is basically both sides, it is coming like this, and this moment we will consider as negative bending moment. This is also called as hogging bending moment. Similarly, there may be another chance of having a different effect on the beam, and that is the beam may bend like this due to the effect of the bending moments at this section. This we know as, or we can say as, positive bending moment or sagging bending moment. So this negative bending moment or hogging bending moment, and this is if the beam tends to go bend in upward direction, we can say as positive bending moment or sagging bending moment. This may look to you little complicated, right? So we are doing it in a simple manner. So first, let me draw this diagram. So if this is like this, we are say it is negative or hogging, and if it is like this, by this help of bending moment, we are saying it as positive or sagging. The special notes are what we have to remember: moment due to every downward force is negative. Similarly, moment for every upward force is positive. Write it down. These 2 points, write it down. So moment for every downward force we will consider is as negative, and moment for every upward force we will consider as positive. Okay, have you written it down?
Yes, sir.
Okay, now we will see how we can find out or how we can draw the shear force diagram or bending moment diagram. Say there is a cantilever beam, okay? Say this is W, and vertically downward force is acting here. The length is saying is L. So we have to draw the SFD and BMD, that is shear force diagram and bending moment diagram. Okay, how we will do that? So we first, so step 1, this is the question to us. A load is there and the length is also given. First step 1, consider any section XX. Say the distance is x from this free end. Okay. Now we have to find out the shear force at this section XX. So step 2, how to find out shear force at this section? What will be the shear force at this section?
W into X.
हाँ बोलो.
X into W. X into
minus W.
shear
minus
force,
W.
हम लोग shear force के बारे में बात कर रहे हैं. Only
W into L.
ना
minus
shear
W.
force. Why the W will be multiplied with L? W तो एक खुद ही force है.
minus W.
Minus W.
Minus W. On which side we are considering?
Plus W. Plus W.
Take any of the case. Say for this case, na right part is be easier na for us, because that's what I have chosen like this. So right part will be easier. So right part में क्या बोल रहा है? Shear force क्या होगा?
Plus
W.
W.
Plus W, because the downward we have already considered as plus. That's what as per the sign convention. Okay. What is the, then first draw the shear force diagram. Okay. Then we will go for bending moment. So this shear force, whatever plus W has come, is it depending upon the section where we
No,
have
sir.
bent?
No,
No,
sir.
right? X may be anything. It will always go for W. So X, if the section was here, 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 anywhere, it will become W. What about here? What about this point A?
W होगा. Wait.
W होगा, but so we know the reaction will act in which direction?
Upward.
Direction of W.
Upward direction, same magnitude. Okay. Now if we think about, again I am telling, for one part will be sufficient, but for better understanding you can do that way. So this is the X direction. So this is our L minus X, although it is not needed, because as we know that W shear force is not depending upon the distance. Now if we think about the left part of the section, what will be the shear force? Just this part.
W.
W रहेगा क्यों? क्योंकि लेफ्ट पार्ट में अपवर्ड इज
Left
पॉजिटिव.
में पर upward है.
तो shear force at B or say X is positive. Shear force at A, that is this point, is also positive. So if this is the bottom line of the shear force diagram, so whatever the positive things we will draw above of a datum line, and if it is negative we will draw below it. So here the W is here for the free end part, entire portion is also W, and at the fixed support it is also plus W. So both the cases it is plus W. Here it is also W, here it is also W. This is our shear force diagram. Is it clear or not?
Yes, sir.
क्लियर हुआ?
Yes, sir.
ओके. अभी तो लंच टाइम है. 5 मिनट अगर दे सकते हो तो और एक चीज बता दूंगा. होगा 5 मिनट? डू यू हैव?
Yes, sir.
ओके, जस्ट 5 मिनट में
Yes, sir.
खत्म कर दूंगा. If tomorrow, next day we will go for the bending moment diagram. Today let me see this case. So this is a simply supported part. Okay, say this length L. At this point of time, these are reactions, okay? This is say RA and this is say RB and this is acting at the center. So what will be these reaction forces? Any idea? This is acting at the center of the L length. Two reaction forces are coming because this is, we have drawn it from this part. In the first slide, we have drawn this simply supported beam. So this will give a reaction, this will give a reaction. So these two reactions are nothing like this A part and B part. What will be these reaction forces?
W by 2.
W by 2, very good. So RA will be equal to W by 2, RB will be equals to W by 2. So we know as now this is W, this is W by 2 and this is W by 2. This is all the reactions and all the external forces. Now we want to draw the shear force diagram. Now we want to draw the shear force diagram. What we will do? We can take a section here, say X distance. What will be the shear force here at this section? Just think about the right side.
Negative W by 2.
Minus W
Minus
by
W by 2.
Very good. So here it is minus W by 2. It is coming here. If we take the section, say here, this is x1, x1. This is say second section, x2, x2. Or we can find so this is, for this case, we can see or we can have a look from the left part or the right part. Which one will be easier for x2?
Left.
Right.
Left.
Left.
What will be the shear force?
W by 2.
Negative.
Sign भी बोल दो. What W by 2?
Plus.
negative W.
Plus W by 2.
We are now thinking about the
Opposite.
left part. So left part upward.
Positive.
Plus.
Positive.
Plus W by
Positive.
2 and here it is minus W by 2. Okay, so here the bending moment diagram will be, so this is the case, this is L by 2, this is L by 2, this is L, the reaction forces are acting like this. So the shear force diagram will be, this side it is minus W, this is the datum line, okay. So minus will be acting here in the below and plus will be acting here. This goes like this. So this is plus W by 2. This is plus W by 2. This is also W by 2 from here to here, but negative sign. And this is also W by 2. So this is the shear force diagram for a simply supported beam if a concentrated load acting at the center point. Okay, ठीक है, आज थोड़ा अभी बंद करते. क्लियर हुआ जितना भी बोला आज? कॉन्सेप्ट
Yes,
समझ में आ
sir.
गया?
Yes, sir.
Okay, so I am stopping it here and yeah, okay. I have shared the attendance link.
No longer accepting responses are
अभी हो गया